Hello everyone. Uh, I am Nikita Hazare uh, from TY Computer of Engineering MITOE and now I am presenting the topic of understanding long short term memory network, that is LSTMs. Long short term memory network are the type of recurrent neuron network architecture designed to model sequential data and overcome the limitations of a traditional RNNs. They are capable of learning long-term dependencies and are widely used in various fields, including natural language processing, time series analysis, and speech recording. Principle of LSTMs. First principle is a gate structure. The key principle of LSTMs lies in their unique gate structure, including input, forget, and the output gates. These there are gate related the flow of information, allowing the network to retain and utilize relevant information over long series. Second principle is a memory cell. LSTMs are a unique occupied with memory cells that can maintain information of a long duration, preventing the vanishing guarantee problem commonly found in traditional RNS. These enable to able network to efficiently capture long-term dependency in data. Third principle is activation functions. Utilizing specialized activation functions such as the sigmoid and hyperbolic tangent functions. LSTMs can control the flow of information and handle the integrate pattern in sequential data effectively. And working of LSTMs. First working of LSTMs is learning sequential pattern. LSTM process sequential data by dynamic updating their internal states. Allows terms to capture both the short and long term pattern. This enable them to understand and predict the sequence with a high accuracy, handling the various input length. One of the strengths of LSTMs lies in their ability to handle input sequence of varying length. This feasibility makes them suitable for the wide range of applications with a diverse data structure. Long-term dependencies modeling, uh, uh, unlike traditional RNNs, LSTMs excel at capturing long-range dependencies, make them ideal for the tasks that require understanding context and pattern across the extended sequences. Advantages of using LSTMs: robust to vanishing mm, gradient problem. First advantages, and LSTMs are designed to mitigate the vanishing guarantee problem, ensuring effective training and learning from long sequence without loss of information. Second advantages is efficient handling of a long sequence. They can process and understand complex pattern which long sequence make them well suitable for the tasks such as language transaction, speech recording, and sentiment analysis. Third advantages is flexibility in data representation. LSTMS offers a versatile approach to representing and modeling sequential data, uh, enable to creations of in intricate and accurate predictions model. And limitations of LSTMs. First limitations of LSTMs is sensitivity to hyperparameters. Um, means closing suitable hyperparameter for LSTMs is crucial, and if your selection may lead to difficulties in convergence and proportional performance. A second limitation is complexity in a training. Training of LSTMs effectively requires extensive computation effectively for a larger scale data set, which can increase training time and resource requirement. And third limitations is difficulty in parallelization. LSTMs exhibit challenges in parallelizing operations, particularly across longer sequences, limiting their scalability in certain scenarios. Applications of LSTM. Yes, first applications is a language transaction. LSTMs are widely used in machine learning transaction system to understand and process input sequence in one language and generate accurate transactions in other language. Second application is a speech recording. They play a key role in a speech recording application, accurately transcribing spoken language into text with a high precision. And third applications is sentiment analysis. LSTMs enable to analysis of a sentiment in a sexual data, allowing for the categorization of opinions and as a possible positive, negative, or neutral with a contextual understanding. Acceptations in LSTMs, particularly partially observable environment. In scenarios with a partial observability, LSTMs may face challenges in currently representing and predicting future state, affecting their performance. Extreme data enable imbalance. When dealing with a highly imbalanced dataset, LSTMs might struggle to effectively learn and represent the minority classes, impacting their predictive capabilities. Noisy input data. Noise in input sequence can lead to ambiguity and distort the representations. Learning by LSTMs, diminishing the reliability of the network prediction. Considerations for data scientists and researchers. First is understanding model complexity. Data scientists should carefully evaluate the complexity of LSTMs and their suitability for a specific task, considering computational resource and dataset characters. Optimizing uh, training strategies. Researchers need to explore efficient training strategies for LSTMs, including regularization techniques and adaptive learning method, and to improve model generalizations and performance. Exploring neural exploring novel architectures. Continuous explorations of novel LSTMS architectures and variations can lead to breakthrough in handling long-term dependencies and enhancing predictions accuracy across diverse domains. Future development and innovations. First is enhanced memory mechanisms. Future developments may focus on the refining the memory mechanism with LSTMs to address to challenges in capturing and utilizing information over extremely long sequence. Second is contextual adaptability. Uh, Advancements in contextual adaptability can enable LSTMS to more effectively comprehend and process diverse contextual information, leading to improved prediction ability. Integrations with attention mechanism. LSTMs can benefit from enhanced integration with attention mechanism, allowing them to selectively focus on the relevant part of input sequence, enhancing performance in the various application. And now, conclusions and a final remark. First conclusion is a uh, continual advancements. The continuous advancements and refinement in LSTMS architectures and training methodologies positions them as a pivotal tools in handling complex sequential data and unlocking new possibilities in the machine learning and data analysis. A need for the domain specific adaptation. Adapting LSTMs to specific domain and applications area, considering the unique characters of the data and the task requirement in crucial for the maximizing their potential impact. Uh, Third conclusion is collaborating explorations and knowledge sharing among data scientists and researchers are is essential for during the evaluations and utilizations of LSTMS in diverse field for of study. Thank you very much.